Hello again, everyone. Today we're going to complete our 3-video series about high availability with a look at SMS HA. The TippingPoint Security Management System is a server that can manage and administrate all your IPS TPS products from one user interface. That capability is critical for day-to-day operations, and while these servers are tough customers, problems can still arise that would put it out of operation, which can impact SecOps. SMS HA allows you to put 2 SMS servers into an active-passive cluster, so that if the primary device becomes unavailable, the secondary device can then take over and act as the primary while you sort out the problem. The initial configuration of the cluster synchronizes the database from the active SMS to the passive, and replicates new data to the passive regularly to keep it current. The pair keeps in contact with one another using a heartbeat mechanism. And if the passive SMS is unable to communicate with the active SMS for any reason, it'll take over the role as primary in order to preserve the availability of device management and reporting for your organization. The connection between the 2 devices is pretty important then, for obvious reasons. You can configure the pair to send information over one of 2 network ports, the public interface or a private intra-cluster interface that connects the pair directly. Using this private interface provides another level of redundancy. If something happens to disrupt the heartbeats being delivered by that direct link, they'll attempt to pick it back up through the public network before they initiate a failover. SMSs who are located too far apart to use that private interface will need to use only the public interface, with the understanding that a minimum amount of bandwidth is required for successful replication. Also, to avoid unnecessary failovers, ensure that link has a latency of less than 300 milliseconds. In situations where latency is unavoidable, you can increase the HA timeout values to help prevent a failover. These settings can be found by clicking the Timeouts button in the HA Cluster Status section of the High Availability screen, which we'll see in just a bit. There's also a series of ports that need to be open in your network to allow this communication, and here they are. Feel free to pause the video right here and take some notes. Otherwise, you can find this list in the SMS User's Guide. The clustering capability of the SMS also has some prerequisites, mainly that both devices be configured identically. There's a bit of leeway on hardware resources, but failing over to an SMS that doesn't have the same capabilities as the primary could cause performance issues on that device, so we recommend keeping their specs as close as possible. You'll notice a couple of gotchas listed here as well, the most common being that if you use SNMP in your organization, you'll need to configure it on both SMSs before putting them into HA, as it can't be modified on a passive device. That also means if you need to make a change to those settings, you'll need to break HA to apply those settings to the passive as well. Similarly, upgrading the software on one SMS doesn't automatically update the software on the other, with the exception of minor hotfixes that don't affect the underlying database. For this reason, you should also plan to break HA, perform a software upgrade on both servers, then put the units back into HA for normal operation. Now, while this all may sound complicated, it's really not that difficult. For today's demonstration, we're going to walk through the creation, modification, and deletion of an SMS high availability cluster, and we'll be performing these steps on a pair of SMSs running 5.30 code. The HA configuration screen can be found from the Admin tab of the SMS client. From there, you'll choose High Availability on the left-hand side, then you'll see the HA Cluster Status section at the top. As HA isn't configured at this point, all the buttons are grayed out except for Configure, which is how you get started. Clicking that button will pull up a helpful wizard to guide you through the next steps. Click Next to get to your first choice regarding event data replication. Event data is useful for research, but takes up the lion's share of data transmitted through synchronization. If you've got copies of these events already being sent to a syslog server, as many do, it may not be necessary to continuously copy the event table to the passive server. Likewise, you can encrypt the communication between the servers if they're talking over your public network. Clicking Next brings you to the timeout settings page I referred to earlier. Here you can see a spot for total heartbeat timeout, which refers to how long the servers will poll one another before declaring a problem, and the mitigation timeout, which is how long the passive server will attempt to fix the issue before it gives up and takes over as the active server. The maximum time the SMS spends on HA recovery is the sum of these 2 fields. So in conditions where latency is unavoidable, you'll want to set these timeouts to their maximum to help prevent this type of failover. The third screen lets you choose which type of connectivity you want between the pair of SMS servers. As we discussed, using both interfaces is best practice if the servers are close enough for direct cable connection. For this demonstration, we'll be using primary only, as I'm operating with virtual SMSs that are unable to connect to one another with a cable. The next screen allows you to choose an optional shared virtual management IP address. This must be a unique address, different from the actual IPs for the active and passive SMS, but it must also reside on the same subnet. This allows all managed devices and SMS clients to connect to the same IP, no matter which server is actually active at the time. Regardless of whether you use this shared option, you'll need to input the address for the passive server in the last field. If you've elected to use the secondary network interfaces to allow direct communication between the SMSs, clicking Next will bring up a screen where you can make changes to the private and gateway IPs for that connection, or just click Next one final time. This last page needs the login credentials for a user on the passive system with permissions to enable HA. Once you've entered them, click Configure. You'll notice now that the status of the HA cluster is showing as enabled, but you're not quite finished. To complete the process, the two servers need to synchronize their databases so they can begin regular replication. You can choose whether or not to synchronize historical event data here, but just be aware that if a large amount of event data is present on the primary server, this will extend the amount of time needed for synchronization to complete. We'll start the process here, and I want you to notice that synchronization temporarily disconnects the SMS client while each SMS automatically restarts. You'll be presented with a synchronization status screen that keeps you abreast of its progress. After synchronization is finished, you'll see that the HA cluster status as enabled and the Synchronize button grayed out because the cluster is healthy. Issues with network connectivity or other software or hardware issues that result in a state of degraded will light up the Synchronize button, requiring you to sync in order to restore the healthy condition. Congratulations! You've got a healthy SMS HA cluster. The SMSs will now fail over automatically if there's a problem with the active server. But what if you want to take one of the servers offline to, say, replace some hardware? You can do this anytime on the passive by simply shutting it down via the power button. The HA cluster status will simply read degraded, unable to communicate with peer, and you'll need to synchronize when the passive is up and running again. But what if you need to work on the active server? No problem, we provided the failover option for just such an occasion. Invoking a failover not only promotes the passive server, but deactivates the primary server, allowing you to take it offline for routine maintenance. Let's do that together now. From the High Availability window, we'll just click the Failover button. Notice that the warning message says neither a restart or synchronization is performed. Click OK. The status changes to peer takeover pending. Then the client resets. Just relax at this point. The process will take some time to complete, but when done, the client will automatically log in to the newly activated server and bring you back to the same high availability screen. Note that the cluster status now says degraded, and the passive server's IP is listed as active. At this point, you'd be free to power down the original server and do whatever work is required. When that's done, turn the power on and watch the console to make sure the unit completely comes up. Once it has, return to this functioning SMS client and simply click Synchronize. Once this part finishes, the client will log back in again automatically, but you'll see that the cluster status is healthy with the original SMS back in charge. There may also be situations where you need to just swap the roles between active and passive permanently, and this is done by clicking the Swap button. Similarly to failing over, the process will take several minutes, during which the servers are restarted and the cluster is resynchronized. The client will again temporarily disconnect until the cluster has returned to a fully functional state. Unlike a failover, the now passive server is not deactivated, but simply assumes its new role moving forward. Last but not least, you can disable the cluster altogether by clicking the Disable button. This is required, as you may recall, to install software upgrades and patches, as well as most hotfixes. Disable HA, install the software on both devices separately, and then reconfigure the cluster from scratch. And that wraps up our how-to for SMS High Availability. If you have any questions, feel free to reach out to our TippingPoint Technical Assistance Center. And thanks so much for watching.